All right, welcome to the explainer. It's one thing for a computer to see a photo and say, hey, there's a cat in there. But what if it could tell you exactly where that cat is? That's what we're diving into today, how we teach machines to go from just seeing to actually, knowing.
So let's get right into it. We're all super used to our phones sorting our pictures, right? It knows this one has a dog, this one has a car, and that's incredible stuff. But is that all there is to it? Is that the whole picture?
Because let's be real, a lot of the time the most important thing isn't just knowing what's in the image, but knowing precisely where it is. I mean, that's the fundamental leap we're talking about, and it's a huge one. It's the difference between a neat little photo app and something like, say, a self-driving car that needs to make split-second life-or-death decisions.
Okay, so before we can really tackle the where, we've got to start with the basics. And the basic first step is just identifying the what. This whole process has a name. It's called image classification.
So take a look at this. An image classification model looks at this entire picture and just slaps a single label on it, emergency vehicle. And hey, it's not wrong. But that's all it gives you. It's just the what. It has absolutely no idea where that vehicle is in the frame, which you can imagine is kind of crucial information for something like a self-driving car or a smart traffic system.
Right. So how do we get from just what to what and where? How do we combine those two ideas to build something way more powerful? Well, that's where object detection comes into play.
And here's the difference, laid out side by side. It's really simple when you see it like this. On one hand, you have image classification, which is totally focused on the what. But then you have object detection. And that's the game changer, because it adds that critical second piece of the puzzle, the where.
So if we're going to get technical for a second, this is the formal definition. Object detection isn't just one thing. It's actually two jobs happening at the exact same time. First, you have to find the object. We call that localization. And then once you've found it, you have to name it. And that's the classification part we already talked about. Okay, so if the task itself is so different, it makes sense that the way we teach the computer has to change too, right? And like with pretty much everything in machine learning, the secret ingredient, it's all in the data.
For plain old image classification, the training data is super simple. I mean, look at this table. You've got an image on one side and a single label for the whole thing on the other. That's it. Nice and easy.
But for object detection, whoa, that's a whole different story. The data has to be way, way more detailed. We can't just have a label. We need coordinates. Think of it like a GPS address for the object right inside the picture.
And it all comes down to these four little numbers, xmin, ymin, xmax, and ymax. That's all it takes. With just those 4 points, you can define a perfect rectangle, what we call a bounding box, that draws a tight frame right around the object we care about.
So, the big question is, how on earth does a machine learn to draw these boxes? Let's walk through a really clever, though kind of simple, first idea for how to do this. Okay, here's the basic idea. Imagine you have a tiny little window or a patch. You're just going to slide that window across the entire image bit by bit. And for every single little spot, you run a simple classifier that just answers one question. Is the object I'm looking for in this patch? Yes or no? That's the whole algorithm.
And the reason this is so clever is because of how it reframes the problem. We're not trying to solve one huge, complicated problem anymore. Find the object somewhere in this giant image. Instead, we've broken it down into hundreds or even thousands of tiny, easy problems. Is the object right here in this little box?
Now, this patch method is a pretty good start, but you can probably see a problem, right? It might give us not just one box, but a whole bunch of slightly different, overlapping boxes that all say, yep, the object is here. So that leads to a really important question.
Yeah, if our algorithm spits out multiple positive boxes, how do we know which one is the best one? How do we measure how good any single prediction is compared to the actual correct answer?
Well, the answer is a surprisingly elegant little formula called intersection over union, or as everyone calls it, IoU. Now, the name sounds kind of technical, but trust me, the idea is super simple. It's just a score that measures how much our predicted box overlaps with the real ground truth box.
And the scoring is just beautiful in its simplicity. It's a number between 0 and 1. A 0 means your prediction and the real answer don't overlap at all. Total miss. A perfect score of 1 means your predicted box and the real box are exactly the same. A perfect match.
All right, let's make this real. Here's an example of a pretty poor prediction. You can see the predicted box just barely overlaps with the ground truth box. And
Unsurprisingly, it gets a low IoU score, 0.4. Not great. The number tells us exactly what our eyes can see. It's a bad fit.
Okay, now let's check out a much better one. I mean, you don't need to be a computer to see that this is a way better fit. The overlap is huge.
And boom, the score reflects that, 0.92. That's a fantastic IoU. This is the magic right here. It's how a machine can stop just seeing and start knowing if it did a good job. It turns a visual that looks about right into a hard number.
So you see, IoU is really the final, crucial piece of the puzzle. It lets us sort through all the possible predicted boxes and pick the absolute best one. And, even more than that, it gives us a single powerful number to judge how good our entire object detection model is. We can literally put a score on its performance.
And that, right there, is the core idea behind object detection. So the big takeaway is this. By adding that where data, those bounding boxes, to our training, and by using a clever metric like IoU to measure success, we make the leap from just naming a picture to achieving real, genuine spatial awareness. So the real question is, if a computer can do this for a single photo, what happens when it starts doing it for a live video feed, making decisions in real time? Well, that's where things get really interesting.